Coming up next on the IP Talk stage, John Swanson from Synopsys, presenting DesignWare IP, a proven path to silicon success.
In terms of how we think about it today, you know, the cloud infrastructure. You know, we're all talking about the cloud now. You'll see many companies here talking about the cloud. If you have an iPhone, you're probably backing up your data on the cloud. So it took a lot to build this infrastructure, you know, from the compute power, the software to run it, the different medias and formats that are up there are all part of it. Mobile, it's mobile everything now, right? I mean, there was a time at DAC when people had pagers. A couple people had cell phones. I've been coming to DAC a long time. I remember those days. So you went for the cloud, you combine mobile infrastructure, and it's all leading to smart everything. And this is going to happen sooner rather than later, and it will impact the kind of chips that you're doing. And the next is to sort of look at the, you know, how much is in these chips that you're doing. And this is a chart, you know, that goes all the way back to 1978 with forecasts out to 2015. And we're here right now, right, in 2011. So you just look at how much electronic content is in the systems today. I mean, think, you know, a few years ago, who'd have thought of Ethernet in a car? But your infotainment system, you know, that heads-up display, that maybe you have a wireless hotspot, interfaces with your Bluetooth, your radio. This is actually being done with Ethernet in a lot of cars today. Who would have seen that? And we map this into that, and you kind of see how the chips we've designed and the markets we're going into have all gotten more complicated, and these are the chips that you have to design and you have to verify, and a big part of this is the IP that goes on those chips. You know, it wasn't that long ago when you needed a USB, you say, okay, we've got a team of engineers, we can design a USB. And you had maybe 3 years to get that chip done, get that product out to market. Well, today, because of the life cycles, you got to get that chip done quick. You've got to get it out to market. I was at one of the pavilion sessions today, and people were talking about, you know, how risky it was to use the advanced nodes because, you know, some things were a little bit harder to do, and it could delay your chip. And one of the companies commented that, well, yes, it can, but if you really work and, you know, focus your product and make sure, you know, you're using what you need and not trying to take advantage of everything, maybe, that you could get your chip done faster. And so IP is really factored in to this whole thing. Now, the next thing to look at, and this is from a Synopsys Global User Survey, is the trends that are driving process migration. So we do surveys from our customers, and one of the things we always ask is, you know, what geometry are you using? Because, you know, this is important to us. It's not only important in tools, it's very important for the IP, because some IP is synthesizable, like a USB controller. Some IP is very tied to the process, like the PHY for that USB. Maybe, you know, your A to D converters and your memories and things like that are all very tied to this process. So the last time we did this survey, you can see most people were in the 40, 45 range. Current project, quick movement to 28 nanometers. You know, so this is a big deal for the IP guys, right? So we got to get all our PHYs ported before you get here. So you're doing your chips now, mainly in 45, some 32, 28, but your next one is moving down, right? And what's your next one going to be? Well, next one we're seeing 28, huge, 20 taking off, and some people are even smaller than 20 nanometers. So we need this data so that we can make sure as an IP provider that we have the hard IP that you need when you're doing these projects. So if your next project is 28, you can bet the IP providers are already working on getting their IP ported to 28. Now, power is another big thing. We've talked about power for many years. It is just becoming so important. I mean, you know, just the cost of energy, I'm sure everybody here's energy bills have gone up. We often think about power in mobile communications because we don't want our phone to die when we're at a show, but it's a lot more than that. You know, I live in Oregon, and we're lucky. We have pretty good power supply with the Columbia River and the dams. So companies like Google and Facebook are building huge data centers where the power is cheaper. And federal governments are now mandating low power solutions on things that plug into the wall. You didn't used to think about, you plugged your computer in and who cares, right? It stays on. But if you just consider Ethernet as an example. We introduced energy efficient Ethernet not too long ago. There were things before like AMD Magic Packet, which could put a computer in standby, wake it up. But now we've got IEEE standards, energy efficient Ethernet, so that you can actually shut things off when there's no packets going. If you look at how active an Ethernet port is on your computer when it's sitting there, there's a lot of wasted energy. Going forward, US, European, and Asian governments are mandating that as a product, if you want Energy Star compliance, you're going to have to support things like energy efficient Ethernet. So the times have changed, the requirements have changed, and that falls on you. And do you just try and update something old, or do you maybe need to redesign that product, bring in IP that can be easily updated, and support these advanced features? And the other thing is, if you look at 2010 compared to 2011, many, many more people care about it, and the number of gates has just exploded. 13% greater than 100 million gates. So these are big designs. So you walk around the floor and you'll see lots of companies talking about how they can help you save power. And that's also a key role of IP. If it's data path IP, you can optimize a data path to take certain structures that'll reduce power. If you think of just A times B plus C, it sounds very simple. The logic actually gets quite complex. You can organize the gates in synthesis to give you a more power optimized structure. And that is one form of IP you can get from Synopsys. And they keep getting faster. So, this is, I think, is quite impressive. Right now, over 42% of the designs are, 500 megahertz plus. Now, in mobile communications, high speed is not always what you want. So we talk about saving power. So if I'm designing a cell phone, what's usually on? The receiver is usually on. So there's the turbo encoder, the turbo decoder, and things like that. We often, as chip designers, think, we got to make it faster. We've got to make it faster. Well, we want to save more power. So we actually, in signal processing DSP type of IP, we want to make it slower. You want to be able to build a 4G LTE modem with as slow of a clock as you can and still be able to get all the data in. Affects power. Again, it affects the IP. And if you think of something like a turbo decoder and the kind of chips that people are building for wireless today, you've got to support a minimum of 4 different standards. LTE is the newest one, and pretty soon, if not already, people are going to start testing LTE-A. And then when you're building a chip, you're going to need to support LTE and LTE-A, as well as the other formats, because LTE won't be everywhere. It wasn't even that long ago when you couldn't get an international phone. Now, all the phones work everywhere. Big reason I bought my first iPhone was I got off a train in Korea, and I saw these people pulling out a phone, and I started, talking on the phone, and I'm like, your phone works here? Korea and Japan, the different networks and the phones didn't always work, and they were iPhones. And they said, yeah, iPhone works everywhere. It's great. I thought, wow, I got to get one of those. And I did. And I love it. It's a great phone. So anyway, clocking frequencies are a big part of your design. More aggressive power management. Once again, from a Synopsys survey, February this year, 2010, 2011. Just look at the differences. There's more things to save power that people are paying attention to, and more people are worried about this. So it's not just consumer products, it's not just battery products, it's every product. And it's in automotive now too. So I talked about Ethernet in an automotive design. Well, what if that car is an electric car? Every little bit of power you draw is going to drain the battery more. So now we have to start thinking about power in a car. We never used to worry about that. It's got this big engine, it's running, it's generating power. Who cares how much it uses, Put the big speakers in, run it on the big battery. But if it's an electric car, you probably care a little bit more about power. So all the different techniques from clock gating, multi-voltages, being able to set up different domains, things that were pretty common, now you're seeing, DVFS, low power suppressions, state retention, things like that. A lot of this can be part of the IP. And so when you're looking at IP, these can be key features. If I'm adding Ethernet, do they support energy efficient Ethernet? Do they provide, a UPF file, for example, so that you can control voltage domains? Is all this part of your IP? Because it's all going to be part of your chip, and you need to put it all together. So Synopsys has been a serious IP company for a very long time. As I say, I've been in the IP business with Synopsys for over 20 years. It used to be a secret that Synopsys was doing so much IP. And you look at what we've built over the years, from internal development and other ways, we now provide a broad portfolio of IP. And this is something that can help you do your chips. We have over 1,400 engineers in the IP group. So that's 1,400 people working on making sure that USB 3 works properly, making sure your Ethernet MAC has all the latest features, that your PHYs are ported to the latest processes, certified and tested, that you have the floating point and data path components that work with your synthesis tool so that you can get the best quality of results. It is a significant business for Synopsys. We are proven, and we are there to help you succeed in your chip. Now, we're always releasing new things, and this is a recent update with our MIPI MPHY. So, great article came out in EE Times. We support all the new formats, so there's 6 protocols that the MPHY has to work with, and we don't just design the IP and claim. We take the IP through certification. We have what I like to call the mad scientist laboratory, where the engineers get a test, and we'll talk more about that in a minute. We support all of the high-speed ranges, Gear 1, Gear 2, Gear 3. It's a scalable architecture, which is designed not just for the chips today, but we're also looking forward and involved in the development of the standards for the next generation. So, we're not sitting on the sideline and then trying to catch up. We are very much a part of the standards committees, developing the standards, working with the different companies, and making sure we're going to have the IP you need when it's ready. Very low power, low latency, and small. Because even though a lot of my customers say area isn't my biggest concern anymore, it's IOs, which for me it took a few knocks in the head to get that straight. Because when I first started, it was all about area. Got to get the area down. Got to get the area down. Now, yeah, we think about area because we're going to put a whole bunch of memory on the chip, but it's IOs that are the biggest restriction many companies are running into. We are fully compliant with the 1.0 specification. Last year when I did this talk, we had a relatively new technology that we'd acquired through the Virage. We fully folded that into the Synopsys family now, and we recently announced the new 28 nanometer memories and logic libraries. And we've got some wonderful quotes from companies, from Memory Designs, Movitus, where they are using these new, used to be risky geometries. I think 28 is pretty solid right now. I think 20 is probably a little bit scarier, and some of the smaller ones are even more scary. But these are available, production release, that you can use. So if you're using a 28 nanometer process, go to our web, look for the 28 nanometer libraries, and you can get a lot more information. Now, we've always talked about keeping up with Moore's Law, and this is one reason why IP has been very successful. If you had 3 years to design your chip, you could do your own USB, you could do the update, but now you've got to get that chip done quicker. So you kind of go back to 2005, which is when I would say big IP really got accepted. That's when companies, it wasn't just a make versus buy, it became a time-to-market decision. I've got to get this chip done and out in 9 months. Every week I delay is costing me a lot of money. There might be people here who remember the Motorola Razr. So what did the Motorola Razr do to the cell phone industry? Everybody went into a panic because there was this slim phone that would fit in your pocket very easy, and everybody was running to catch up. How much money do you think Motorola would have lost if that product had been delayed 6 months? Because you know the other mobile phone companies were working on the same thing. So you can get your product out sooner, you're going to make a lot more money. And that makes our bosses happy, it makes the shareholders happy, it puts more money in everybody's pocket. So time to market really became important. And this is where IP blocks really started seeing their own, big IP blocks. The next thing is subsystems. Subsystems. So if I've got a product and I want good quality audio on it, whether it's going through a headset or like an iPhone, there's all these docking stations that they plug into. Maybe instead of trying to buy the individual components, figure out how to wire them all up together, find software, get the software running on this platform, test all that while I'm integrating into the rest of my chip. Maybe I could find a subsystem that would have the hardware and the software and the verification tools that could do all of that for me. So that's what we mean when we talk about subsystems. And as an IP provider, we're stepping up and we're taking IP to the next level. So about a month ago, we announced the new DesignWare Soundwave audio subsystem. It's not just RTL. It's a complete solution. So it has all the hardware that you need, RTL, so that you can put this on your design. It's a 32-bit audio processor with various digital interfaces and codecs. Uses an AMBA interface, so you can easily bring this in to your design. In addition, we provide the software stack. And this is a key part, right? We spend a lot of time getting hardware and software to work together. So it's a complete software stack with audio codecs from Dolby and SRS. Now you're going to want to test this in your product. So we're also providing virtual prototypes of the subsystem. So you can take that virtual prototype, you can link it with something like a HAPS system from Synopsys, put your RTL on HAPS, run the virtual prototype, and do more testing. So now you've got something where you can almost in real time see how that audio subsystem is working in it. And I mentioned HAPS, that's for your FPGA prototyping. So we provide hardware, software, virtual prototypes, and an FPGA environment, all designed and tested for this audio subsystem to make your job easier. We've got to do quality right. With IP, quality is critical. I'd like to say there were never bugs, but it's software, and the reality is that software, sometimes there are bugs. I did a seminar in China a few years ago, and as they were briefing all the speakers, the head of the Chinese Academy of Science comes up and says, nobody is allowed to claim their software is bug-free. If any of you claim it, you will be taken off the stage and not be allowed to finish your paper. Somebody didn't believe him and actually claimed there were no bugs in their software. They turned his mic off and took him off the stage. So, unfortunately, there are bugs sometimes. You need to be open as an IP provider. And so all Synopsys IP customers can go to our web, see any issues with any configuration of any core. But they've got to be correct, they've got to interoperate, and you've got to have the support. And we provide all this. I've talked enough about the deliverables. Now, I mentioned the Mad Scientist Lab, so this is one of my favorite things. In the Oregon office, we actually have the SATA Interoperability Lab, and we do a lot of the PCI testing. These labs are scattered all over the world, and I'm kind of envious. And there's a reason why your badge doesn't let everybody into these rooms, right? Look at the USB interoperability. That's just a small collection of the things they test with. Our USB PMM, he literally is constantly looking for new USB things to test with our cores. And he has everything from Goldfish to anything you can imagine on a USB, every kind of flash drive and all that stuff. And we test. We put it on the FPGA, when we do updates to the cores, constantly plugging in different devices. I think we have every SATA hard drive on the planet in the lab. So we do serious interoperability testing. And our customers trust us. We're lucky. Many of our customers are willing to talk publicly about what we do. So DisplayLink, Global Unichip, Open Silicon, Fairchild, and many, many other companies are willing to talk about how we've helped them do their chips and can reduce their time to market. Many of the cores you'll find, you can go to the Synopsys web, and you can actually download what we like to call success stories, where customers talk a little bit about their project, why they picked the IP, how it works. Some of these success stories include multiple IPs. So that concludes my presentation for the day. So if there's any questions, I'd be happy to answer them.
Yeah, if you have any questions for John, if you would like to come over to our demo station, we'd be happy to show you how quick and easy it is to access the Synopsys IP catalog on ChipEstimate.com. So stick around. We're going to give you a ticket for a drawing that's coming up very, very soon. And so you can stick and stay for our presentation. We'll do the drawing for the Kindle Fire right after. Thank you so much, John Swanson, right here.